Hello everyone, welcome to Lab 3. In this lab, you'll be building first order plus time delay models for your systems in whichever station you're working in. So I would suggest you to watch this video after reading the manual a bit so that it'll be easier for you guys. And if you have any questions regarding this lab, please drop us an email. The safety considerations for this lab would be to wear proper PPEs because we are going to work with steam in this lab. So a lab coat, safety glass, and closed-toed shoes are compulsory if you're doing the experiment in the lab. And please follow safe startup and shutdown procedures. And also please don't touch any hot surfaces in the lab so that you don't burn yourself. We have seen in lab 1 that we have 3 stations in our process control lab, so P1, P2, and P3. So we have one on the left, one on the center, and one on the right. For the purpose of data collection, we have done the experiment in station P1. The system under consideration here is a tank with the heater. So steam is used to heat the water. And if you read through the manual, you'll find that the steam flow rate would be the manipulated input, and the output variable would be the temperature of the liquid in the tank. We'll be giving step inputs of magnitude given in the manual, and then we'll measure the liquid's temperature in the tank, and then do the analysis on the data collected. Let's take a look at the startup procedure. We are using pneumatic valves to control the fluids. So we are turning on the cold water supply and the air supply. And in this experiment, we are using steam also. So the steam valve is on the top of the station, so we open it. All the other controls can be done from the Delta V computer system. In Lab 3, the task is to develop transfer functions for your system in 2 different operating conditions. One will be the nominal operating condition and the worst case operating condition. And if you read through the manual, you'll find more information about transfer functions and the inputs and the outputs. There will be one drain valve in station P3, so set the drain valve to 40 degrees if you're in station P3, but for the other stations P1 and P2, fully close the shorthand valve. And then set the longhand valve to 35 degrees. So there are degree markings, so we set at 35 degrees. The station is set up, then we can go to the computer station and then do the other things in our Delta V system. So we first set FIC104 to cascade mode, which is the flow meter, cold water flow. And then we go to the level controller, LIC101, and then put it in auto mode there because we are going to give it a constant set point of 0.2 meters. So if you go and click on the box and then you enter 0.2, so then this tank starts filling up with water here. So wait until it reaches 0.2 or until the water covers the steam coils, and then switch on the steam flow meter, put it in. Yeah, so put the steam flow in auto mode and then give the set point as 15 kilograms per hour. So this will be the starting point. And then we wait for the system to reach steady state, which means the temperature of the tank should reach steady state value, and then we start our experiment. You can see the color legends at the bottom of the screen. So the temperature of the tank is marked in olive green color. For each of the settings, we'll be doing 3 step tests. Initially a positive step test, and then a negative step test, and then finally a positive step test again. So for both nominal and worst case conditions, we'll be doing 3 step tests. So let's do the first step test from the starting point. So we go back to the Delta V screen and we click on the steam flow rate. and plus 5, so 15 to 20 we set the steam, so we can see that the steam flow rate starts increasing. So if you increase the steam flow rate, then the temperature of the liquid in the tank will also increase. So this is our first step test starting from our initial point. So we can see that the temperature of the tank slowly increases and then reaches a steady state value. So after it reaches the steady state value, we can go to our negative second step test, which is a negative step test. So after our first step, we'll be at 20 kilograms per hour. So negative, so we'll come to 10. So we decrease it to 10 kilograms per hour, and then we see how the temperature of the liquid in the tank behaves. So the red line is actually the flow rate. We can see that it is moving in terms of step, and the olive green is the temperature of the liquid in the tank. So you can see that the steam flow rate has decreased to 10. So the temperature of the liquid is slowly decreasing. So we wait for it to reach steady state again. So this might take a couple of minutes if you're actually doing it in lab, or even 5 minutes to 10 minutes, depending on the station you're in. After it reaches steady state, then we do the final positive step test, 5 kilograms per hour. So we are at 10 kilograms per hour currently. So we go back to the delta V screen and then increase it by 5. So from 10 to 15. Then click on OK. So the steam has been changed to 15 kilograms per hour again. And then we wait for the temperature to reach steady state. So after it reaches steady state, this completes our experiment in the nominal case setting. If the temperature reaches steady state, we have completed our nominal case setting experiment, and then we can go to the worst case setting and then do the step tests again on the system. The only difference for the worst case setting would be the long hand valve positions and the steam flow rate starting point. So here we have to set the long hand valve to 50 degrees. So previously it was 35 and now we set it to 50. And then for the nominal case, we started at 15 kilograms per hour. Here for the worst case, after changing the valve position, we set it at 10 kilograms per hour. And we wait for the system to reach steady state. And then we'll start the 3-step tests again, like we did before for the nominal case. Yeah, so now the steam flow rate is set at 10 kilograms per hour. And we have the same sequence, a positive step, a negative step, and a positive step. So because we are doing the same in the delta V system for data collection, I didn't put the videos here, but we'll be giving you the data which contains both the nominal test case data and the worst test case data. And you have to perform analysis on both of these data and present your results in the report. Because we have finished our experiment, we have to shut down the equipment safely as well. So please pause at this slide and then read through the shutdown procedure. And thank you. Have a nice day.